But if I stop recording and re-record this part 2, will be actually a separate video. So if you wanted to come back and watch just this one, you could do so easily. What do you think? I'm not as mean as I look, dude. You always give me such a hard time. Anyway, so we're going to discuss background concepts and concerns. Most of what I'm going to talk about is the web networking and protocols and HTTP and browsers. That's the part I'm going to smooth through very quickly. Why? We care, but we don't really care that much. All of what we're doing is network communication. And why is that important? The bigger I make something, the longer it takes for you to get it. That's an important concept. That's pretty much the big deal here. So I'm not going to spend too much time on that. We'll describe the role of the modern web developer. We'll explain the difference between static and dynamic web and client server and side development. We'll describe the importance of using frameworks. We'll discuss important concepts relative to server-side web development, including using n-tiered architecture. Explain important concepts relative to client-side web development, including web frameworks, and talk about full-stack web development and IOC. Yay! This is like a whole introduction to the rest of the course. The database that we did, backup for the other stuff that we're going to do. The coding we just did to code, right? But to review. This is really what we're going to be doing throughout, right? We're going to have we talk about the server-side development. That's the back-end development. Then we're going to do front-end development using JavaScript. We're going to be doing that as well. So let's get this party started. So there's some things we need to know ahead of time. Network protocols, networking, what's the web protocols, client-server architecture. Good news, bad news. I am leading the network protocols. You can read these slides if you want. I'm going to go very, very quickly through them. Same thing with networking. Most of you have a basic understanding of what a network is and how a network works. Do we need to know how bits actually move from one computer to the other? No. The details I will talk about, we will need to know. I will make sure that we go over those. But outside of that, not going to talk about it. What is the web? We need to talk about that. Web protocols, need to talk about HTTP a little bit because backend servers actually require us to have some fundamental knowledge of those. And then client server. We know what client server is. Even if you don't think you know what it is, you know what it is. So IP, the internet protocol. How do we communicate from one computer to the next computer? It's IP. Every host is identified using a unique IP address. It's 32 bits, dotted decimal, 192, blah, blah, blah. It's a good example of one. Don't care. That's what we need to know. More on host. The server that you're going to be creating and the client you'll be creating all work on a host, right? They're all going to have an IP address. A host is something that does something. It could be an endpoint, a terminal. It's what we call a terminal. Right? Like your server is going to be a terminal. The client is going to be another terminal. But there could be things in between it. But anything that does something along that path would be considered a host as well. IP addresses and people. IP addresses are not easy, so host names are used. Imagine you're going to tell your girlfriend you want to go to 263.43.64.6694. Nobody's going to remember that. Main reason nobody's going to remember that because I use numbers well above 255, so it's not a real IP address. But nobody's going to remember that. Can you imagine trying to write that down? Could you? You're busy at work. You're going to write down a web address, and it's going to be 4 numbers less than 255. Yes? That's going to work for you? Nope. So most people don't use them. We use a unique name by which a network attached device is well known. Generally human readable, like google.com, right? Google.com actually translates to large numbers of servers. This is what we call a domain name. There's one specifically we're going to use a lot throughout the course, and it relegates to 127.0.0. 127.0.0.1. Right? There's no place like 127.0.0.1. It is your loopback address, which means it's the host that you're on. We're not going to have server situations where you have 6 servers. All of the things that you're going to have are going to run on your own computer. All of it. So localhost is the one we care about. I'm skipping domain name addresses, all those good things. TCP and UDP. Oh wait, we need to know TCP. So UDP, IP actually is computer to computer communication. But what about the applications running on a different computer? What if I got 3 applications? You know, how do I send one thing to Zoom, one thing to I don't know, Internet Explorer. What's the
Microsoft
Chrome?
Edge.
Right? Wait, what's another one?
Microsoft Edge is Internet Explorer.
Edge is another one. Yeah. So whatever. How do I know what's going to there? Right? We don't want, to send our images we shouldn't be looking at. I'll leave it there to our boss on Zoom, right? That's something we don't want to do. How does the computer know which applications it's being sent to? And that's the communication services, TCP and UDP. And their primary job is to provide application to application support. Now, how do I know? They go from port number to port number. So each application would have a specified port and it would go to that port. And so your Zoom would be going to a Zoom port and your Edge browser would be going to another. And those would never get confused. That's important. All right. So World Wide Web, the group of worldwide connected websites. I still can't believe this is a slide. Website is a collection of web pages. A web page is simply a document on the web, right? Yay! Most of you will not be developing a single web page. You will be having a website that you'll be working with, right? But a lot of people use funny words, so I want to make sure we all use the same word. A URL is a specific address, and a hyperlink or a link is the mechanism one uses to navigate from one to the other. Okay, so what makes up the web? The web is really another way of thinking about the internet and its resources. It's a hugely connected network, and really it's about connecting resources to resources, right? So you have 3 basic parts that make it easy to use. You have HTTP, it's the protocol, which everybody knows how to use. And then you have URLs, which is an addressing scheme, right? We have to have a location and you have to be able to get to that location. And then finally, you have applications. The applications use the hypertext transfer protocol to connect to URLs and so forth. Ta-da! We also have to care about HTML. Why? Mostly we don't. No, I'm joking. But HTML is the way in which we just mark up pages. Okay? There was a time when HTML wasn't about making it look pretty. The commercialization of the web is something relatively new, 1994, 1995 kind of thing. But before then, it was about connecting academic resources, and so there wasn't a lot of decoration, but there was like this part is the title, this part is the abstract, this part is the introduction, and so forth, right? So when they say markup, that's really what it's designed to do, is to take a text document, this part is this part is that, this part is that. That was its original design. But of course, got to make it look pretty, right? That way you'll click on it. Did you know they have people at Yahoo and Google that work on the psychological effects of the colors on screen? It might make you more likely to click a link if it's right underneath the words. Second of all, if it's a certain color, it might make you more likely to click the link. Right? That's the level of detail these things, some of this stuff goes. We don't really care so much about that. We're going to do some basic prettying, but that's about it. HTTP is another communications protocol. There are plenty of them, and HTTP actually steals from a large number of protocols from the web. Right? There are large numbers of them, but the real focus is just to go get documents via URLs. Click on a link, and it goes and gets the documents. At one point, HTML documents were simply text, of course. Now they have stuff on them, like images, right? Those things you don't want to, you're not supposed to look at, right? I looked up a pedal pub the other day, and you think I was looking up something crazy. You know what a pedal pub is? Everybody knows what a pedal pub is?
Oh, the one with like the bike, all the people like sitting.
All the people sit around a bike and it's a bar
Yeah.
with a keg. Google it, dude.
I don't want to.
Cool.
I don't need that on my.
So nobody, like, so I live in Lakeview, so I see them every now and again. I think they're hysterical.
So you want one for your house?
No, I just think they're hysterical. Like I see them,
Okay.
you know, I said, I was looking at the name for it, and apparently Pedal Pub is literally the name for it. I thought they would have, I thought it would have a more interesting name.
Yeah.
It's not, it's Pedal Pub. Whatever. I don't personally want one. This is something I'm not personally interested in. Biking and drinking doesn't sound like a whole lot of fun to me, but you know, whatever. Some people like to exercise when they people just like to exercise sometimes. I don't know. But HTTP protocol is client server. The client is the end user. Terminal end user is also called the user agent. But client server means that you're going to ask for something and you're going to get something response, right? That's what client server. That's all you really need to think about. When you go to a waitress and you say, "I want hot wings," she's going to say, "I want what, $10? I don't know how much hot wings are, but let's say $10." And then she takes the $10 and brings you hot wings, right? Whatever that negotiation is, it's still you're requesting something and getting something in return. Reliable data transfer, so TCP on port 80 typically. It's a request response, it's all ASCII, and there's a 3-digit status code associated with each request and response. It's synchronous, so you have to wait for the response. You can't just, you know, like a waitress, right? So you know, waitress, you say, "I want the hot wing." Wait, we said hot wings, right? Because I want the hot wings, and then takes you $10 and she comes back later, right? You are sitting there hanging out with your friends, right? Imagine you're just stuck. Like after you order the hot wings and you're just stuck. Can't do anything else till your hot wings come back. That's HTTP's response. Yay. So this is a message sent by Internet Explorer to get to Roosevelt homepage. You see the get slash, that's the command. And it's asking for a specific resource using a specific protocol. We don't have to care so much about these individual things. I just want to go over a couple of them. For instance, accept. Accept indicates that it'll accept anything. And what language will accept? English US, and so forth. Now, I don't really care so much about all these things, except I want to point out that this is the only part that's absolutely necessary. The part where I ask and what I'm saying I'm asking for something and I'm telling you what I'm asking for. The rest of it is just name value pairs known for headers to help the server manage the request. That's it. But the original request is get slash. What else? I think I have the response on the next. Let me use the mouse because this is being stupid again. There we go. So we have 2 request methods. There are many more methods than these, but there are 2 requests. We have a get and a post. A get is used to retrieve information from a URI. It's generally designed to be safe, repeatable. Post, we send information. So it's designed for operations that have side effects and can't be safely repeated. If you want to change something, you use post. Unlike get, post actually has a body which is used to send information. So this is a response. The first line, again, is the most important and probably part of the only part of the thing that's important, other than the actual, well, there are a couple other things in the response that are important. But the first line indicates, hey, this is the protocol. You asked for something using a protocol. Here's the protocol. And then 200 OK means I got it. Here it is. And so I don't care about cache control, date, expiration. This is all cache stuff. Content type is important. It tells you what it's going to be. But if that's left off, it's still fine. Content encoding is gzip. It means it actually zipped it up and before it sent it. Remember, the smaller it is, the faster it transmits. So, but there are only 3 parts of a message, a response that are really important. And is your first line, which tells you everything's okay. The content length, which tells you how long the message is. And then, of course, the content. Without the content length, they can't actually read the message. Right? Because it's all in, all the HTML, all those things are actually in the message. So you need the length to know when you can stop reading. Yes? But you'll see these typically. There'll be many more of them depending on what kind of server in operation. Sometimes they'll identify the server, sometimes they won't. This one says GWS, which I have no idea what that means, but who cares? Let's talk about the status codes. I think we have enough time. Yeah, we're gonna get to like to now what? All right. Status codes. One is informational. If you see an informational status code, what the hell is going on? They are pretty unusual. And you go, what do you mean? Well, one informational is an intermediate response that indicates the server's received the request, but is not finished processing. That means you submitted a special type of request and it's going to respond, but it's going to say, hey, I'll have the results for you later. That's very uncommon. It was designed for server communication, but typically we get a full 2XX types of request or response saying that we got it, everything's okay, the request is fine. But I don't know, we just don't see it very often. I'd be shocked if we ever, well, we won't see it in this course, but shocked if any of you actually ever saw it. 200 or 2XX is successful. 200 is used when the requested resource is actually being returned. When we used web service for communicating with a Army Corps of Engineers project, instead of sending a 1XX, we sent a 206 or something stupid, like a 200, but like a number that wasn't in use, that indicated where to get the, it gave you a URL where the result would be when the result was ready. Because it would send a ready message later on. But 2XX is a successful, everything's working. 3XX or 200 is the most common. It's indicate when you go and you go to a website and you get a result and you see the web page, that's a 200. Redirection, the request was processed, but the browser should get the resource from another location. 302 is when the browser's been moved. It could be redirect, it could be a variety of things. You don't actually see these. These are, the browser deals with these, right? What you see is you get a redirection. What ends up happening is the browser says, oh, you have a redirection. So it goes and then requests the other resource. And so then you get a 200 response and you get a web page. But underneath, it's dealing with 300s. We don't really care about that. These are the ones we care about. 4XX, this is client error. There's a problem with the client's request. 404, for example, file not found. Right? What does that mean? That doesn't necessarily mean a client's request. Wrong. What if you have a bad link on your web page? That's your fault. It's not the client's fault. It's a bad link. So 4XX is really your problem as well as the web developer. Okay? But it typically means that the request is not processable. It's a bad request. You'll also deal with a lot of 400s, which are literally called bad requests. When we do JavaScript later on, you're going to communicate with a server, and the server is going to say, I don't like what you're giving me. And it's going to issue a 400. So look out for those. Those are almost always us doing something wrong other than the user. Now, the user could type a bad URL in the browser, but most of the problems with web development, those 400 errors are actually our fault. 5XX is going to be your least favorite one. This indicates an error occurred on the server while processing the request. An error is almost always an exception. What happens? The server says, I can't do anything. Throws up its hand, says I can't do anything. Now, good news. Does that mean the server goes down? No. It may mean it can handle other requests. It may mean it can do this. It may mean it can do that. Or it could mean that the server halted for real. We don't know. These are the ones we're going to have to troubleshoot. 4XX are almost always like a logic issue more than like an exception. But we should never present exceptions to the user because the user is a web user, right? So we can't assume that they're going to be like super sophisticated about what these things are. So you can't really, they don't know what to do with them. We have to deal with these errors. 5XX errors are our problem, right? That can never happen. So we have to build, when we're building code, we're going to build it in such a way that it'll never throw exceptions, right? We'll be defensively coding. Caching and skipping, request response, I want to talk about this. So we have the request, initial request, we return the web page. We parse the web page for additional assets, the browser does, and then it requests all the additional assets, and it returns the assets one by one. Thus, the client has the entire web page and it can display it. Now, I'm willing to bet almost every one of you browsed a web page today. All this happens in a blink of an eye, right? This did not take long, right? Even though you have large numbers of things in a page. The typical structure of a URL is a protocol, HTTP://. You remember our, I already closed it, but remember our JDBC URLs? The protocol for there is JDBC, right? And so we have a protocol, you have a web server name, and this one's www.cnn.com. That's where the resource is. We're going to be using localhost for our own services all the time, but that's the web server name. And then we say the folder name, document name, or extension. So for instance, if it's in the showbiz folder /movies.htm, that's where it is. That's the actual resource, right? Where, which folder, and which resource, right? We need all three of these things to actually get resources. You know what URLs are. You know how they work. Hopefully this isn't too confusing for anyone. Okay, so what happens at the client end? Right, we talked about the client has the entire web page. What actually happens when the client has the entire web page? It displays it to you in a web browser. Software application enables a user to display and interact with content. You don't even think about HTTP protocol happening underneath. You just click on a link and boom, you're magically transported to the next page, right? But the web browser's job is to do that, but also is to not beautify the content, but make the content appear in a way that's usable. But it has two basic tasks. So it handles all the connection details. That's the most important. If it didn't do that, it wouldn't be a web browser. But it also displays the content of the web page. How do we do that? Well, web pages are HTML, which are essentially text documents. It was designed to mark portions of a text document according to their meaning. This is a header, this is an introduction, this is a background, this is a paragraph, this whatever. It's really designed for that. But now, of course, we make it pretty, right? So that, users may want to click on this link versus that link. So web browsers format that information for display, so the appearance of a web page may differ between browsers. So now what? All right, I'm going to finish this page and then we're going to stop because it'd be a good place to stop. So typically there are two sides to this equation. Web developer has to know quite a bit about both, but there's too much for you to know everything about both sides. It's too much. So what do? Web developers tend to be something what the world calls a T developer. Someone knows a lot about things, a little about a lot of things and specializes in a couple. Almost every web developer you will run into will tell you, I'm a web developer and I specialize in, right? Now, what happens if that, say they specialize in Angular, right? They're front-end web developers. They also know how to run the backend. They also know how to connect Angular to different backends as well. Do they know how to write all the backend code? Probably not, but their focus, their specialty is this. You're going to see a lot of that in the web development world, where the basic core functionality of the backend doesn't really change that much, except how you actually produce it. So for example, Laravel works very differently from Spring, but it produces the same stuff, right? We'll talk about that in detail when we actually get there. So if you're a backend developer that's special to Laravel, you also know about Angular and how this works and how that works, and different front ends might work with Laravel, but you're specialized in that, right? That's just how it works. But you have to know, in order to do your job, you have to know a little bit about their jobs. It's not enough for you to do what you call it. Now, and one of my students told me the worst part is if you're in a small enough place, you're not just a T developer, you're like, you have to do them both. right? You're the front end developer and the back end developer. So typically, almost every web developer will be specialized in one area, but also subspecialized on others. So for instance, maybe I'm a Spring backend developer, but I also know how to use Angular very well, right? Not super well, right? But I know how to use Angular, right? One of my friends that works for App Properties, one of my students that used to work for App Properties, he's actually works with Angular and Laravel primarily. Um, but he works with both. It's not like you hear online, they're backend developers and front end developers, right? But that's not really how it works. They're often do a little bit of both, but learn to specialize in one. If you go look online, go to dice.com or one of those web pages where they have jobs, you're going to find a lot of full stack development instead of one or the other. Right? They're not looking for a front end developer or a back end developer. They're looking for somebody that can do full stack. Full stack is the combination of the back end and the front end. Ta-da! All right, that brings us to other stuff, which we'll get to. All right, everybody take a cookie except for you suckers that didn't come to class.